Okay, let's do some proportion work. So now let's take all of the students who have ever taken statistics with Josh. So out of, what do I have? I went back and looked at some statistics from my previous classes, and 181 students have taken statistics, sorry, not calculus, with Josh. Of these, or let's see, 181 students, not out of, 181 students have taken statistics with Josh. Of these, 62 have gotten A's. Okay? Now, is that a good proportion or not? Need a baseline to compare it to. So let's just say that usually we would expect that about, let's be kind of high here, and let's say about 20% of students get A's in any class. It's got to be somewhere around there. Probably a little bit lower. If we followed the normal model, it's probably closer to about 10%, but let's say it's about 20%. So notice that my percentage, 62 out of 181, is actually probably higher than 20%. Let's go see, 62 out of 181 is, oh yeah, that's way bigger than 20%. So it seems to be like my students are getting more A's than the general, or what we would expect as a baseline. So let's try to run a hypothesis test to check this. So in stage 1, I might say something like, well, my H naught would be the baseline, would be the assumption. And we presume that the proportion would be about 0.2. The alternative, on the other hand, would say that, well, I'm going to try to prove that Josh did better than the normal, right? Better than what this is, because it seems like his class was actually higher. So I'm going to test it against an alternative that I'm actually larger than 0.2. Notice that my proportion of 34% is not the hypothesis test null assumption or null hypothesis. I am trying to use my sample to demonstrate that I am different from the null. The null is something in the background. So to that end, let's try running a test. So in the second stage, got to find out a statistic and a p-value, hopefully, that'll give me some evidence. So I'm going to run over here, and it was 62 out of 181. So in my calculator, I can do the statistic, 1 prop, z test. And in this particular example, I said that there was 62 successes. No, my null hypothesis first, sorry. My null hypothesis is a 20%, done. In my actual sample, I had 62 out of 181. And I'm trying to test to see if my actual sample gives evidence that I am different from the null, evidence against the null. So when I calculate over here, it looks like I'm getting a z value of 4.794 and a p-value that is not 8. You can't have a probability of 8. The highest probability ever gets is 1. This is 8 times 10 to the negative 7th. It's a very, very small number, very, very close to 0. So again, go back to my page, and my z-score, my evidence, seems to be saying that I had a z-score of 4.79. I'm 4.9 or 4.79 standard deviations away from the average, which gives me a p-value of not 8, not something larger than 1, but 8 times 10 to the negative 7th. So Alt-E, and we get 0.1234567 There's the p-value. And notice this p-value is much smaller than the 0.05. And that means that this is strong evidence that the null hypothesis is false. Under the assumption of the average being 20% or 20% of people getting A's, the chances that I would actually have a class that has the proportions that I have happens very, very small amount of the time, much less than 5%. So my conclusion is I'm going to reject the null. I have evidence that Josh's class does better than a normal class. A class in which 20% of people get A's in any class. That's the baseline assumption. And then my class, which got this proportion of 34%, was higher, but I didn't know if it was significantly higher until I ran the test. And the test says, yes, Josh, it is significantly higher. If there were an error, it would be type 1. Maybe Josh's class is not actually better and that sample was just a fluke sample. Maybe all the students had already taken statistics, or I biased the sample that I took, or I only selected students that I wanted to use in my proportion. So there could possibly be an error. There's always a possibility of error. But if there were an error, it would be type 1 because my choice was to reject the null. I rejected the null. I have evidence against the baseline of a 20% baseline, and I have evidence on the contrary that the alternative is actually larger than 20%.